right, question number 7 is where we will end. This says, the equations you found in item 5b are solutions to the nonlinear system of equations. A of t equals 10 times 2 to the t power, and b of t equals 600t plus 10. Just as with linear systems, you can solve nonlinear systems by graphing each equation and determining the intersection points. All right, so we are going to graph. A nonlinear system of equations is a system in which at least one of the equations is not linear. So we're going to graph these two. And I'm actually going to use a calculator and then transfer them over. Okay. So we're going to start off by graphing 2x plus 1 and then x squared plus 1. And I'm going to change my window. I want to go from -1 to 4, counting by 0.5. And then we want to go from -1 to 6, counting by 0.5. And we're going to graph those. Okay, so we want to pull these over. And I'm going to graph a couple of points. I know that first one is a linear function. So we will have, trace. Okay. So we're going to start at -1. And I'm looking at y1 right now. And at -1, it is at -1. Okay, let's talk about 0. It's at +1. At 1, it's at +3. At 2, it's at +5. And that next one's going to be off, so we're not going to graph that one. But this is a linear function, so I can graph that with a straight line. Like so. Okay. Let's take a look at this next one. We're going to go down to our next function. I'm going to start at -1. At -1, we have a value of +2. At 0, we have a value of 1. At 1, we have a value of +2. At 2, we have a value of +4. And I'm thinking 3 is going to be off the scale. It is. But with this function, remember that it goes down and it comes back up. Kind of curved like so. Something along that lines. It's got like this U shape. That didn't help the situation. But we have 2 points of intersection, and that is where our main focus is. We have this one at 0, 1, and I have this one which is located at 2, 5. So take a moment to get those 2 intersections down, and then we're going to graph our next set of functions. I have x minus 1. So again, we're going to clear these out. I'm going to go x minus 1. Then we go down, and I want to do 3 to the x power. Oh, no. Gotta let it graph now. Okay. Sorry, this should say 3x minus 2. All right, and we want to change our window. So we want to go from -3 to +3 on both the x and the y, counting by 0.5s. All right. And we're going to graph now. Okay. So we're going to trace this. Going to go to trace. I'm going to start at -3, and we're graphing y1 first. -3 is at -4, so that doesn't help me because it's off my grid. We'll go to -2. -2 is at -3, so right about here. We're going to trace -1. -1 is at -2. Going to trace at 0. It's going to be -1. This is a linear function, so I'm going to assume that it continues the same pattern. We've got this straight line here, like so. Now let's graph that second function. So we're going to start at -3. -3 is approximately -1.962963. So close to -2, but not quite -2. So I'm going to be like really, really close to -2, but not quite there. We got -1. -1 is located at oops, sorry. I wanted to do -2 first. -2 is -1.8, so we're getting a little bit further away from -2, but I mean, it's not drastically. -1, sorry, should be at -1.6, so right under the halfway mark, but not quite. All right, we've got 0. 0 is at -1. Then we're going to do at 1. 1 is at 1. And my guess is 2 is going to be off the grid. Yeah. So this function looks like it goes like this. Something like that. So their only point of intersection is at 0, -1. That is their only point of intersection. All right. Now in this next picture, neither one of these are linear. Both of these are nonlinear functions. So let's get to it. We're going to clear our stuff out. We've got 2 times 5 to the x power. Now we're going to go down and do -x squared plus 2x minus 2. And the window is the same as the last one. -3 to 3 and -3 to 3 counting by 0.5. So I'm going to go ahead and graph that. All right, let's trace some of these points. Ooh. Interesting. Trace -3. -3 is at 0.016, so really close to 0. Not quite there, though. All right, -2 is going to be at 0.8, so we're getting a little bit further away, but I mean, we're not drastic here. Let's do -1. -1 is approximately 0.4, so right under that halfway mark. All right, what about 0? 0 is at +2. And my guess is 1 is going to be off the page. Yep, it's at 10. So it's off my page. So we've got this like function doing something along the lines of this. I mean, it's pretty drastic here. All right, let's go down. I want to trace this at -3. That's way off my grid. What about -2? Again, still off my grid. -1. We're getting closer to my grid, but still not there. What about 0? 0 is at -2. Okay. What about 1? 1 is at -1. What about 2? It's at -2. So we've got like this U shape kind of going like this. Whoops. Something along the lines of this. Where's their intersection? There isn't one. No solution because they never touch. No solution. They never intersect. Go ahead and take a moment to get these graphed and copied over. There will be a debriefing on the next slide, so go ahead and take a moment to do that. After you answer your debriefing, please mark this presentation as done.